What is up, people? Hope you are doing great. Here we are in 5-5. Can you believe it? We are cruising along with inequalities, and our old friend, absolute values back. Absolute fun is what that means, okay? Guys, here's what we got to do. So we have to remember absolute values give me case 1 and case 2, right? So we have our first case, and then we have our negative case, if you think about it that way. Our non-negative case, and then our negative case. Anyway, we're going to keep doing what we've been doing, which is solving and graphing the solution set. All right, so the solving part will be new. Hopefully we're getting better at the graphing these. So first thing I would say is this is a less than or equal to, so less than, so the and, we're thinking this is an and, so we're going to look for the intersection of our two solutions. So case 1, right, here it is. Case 1 looks just like this. Get rid of the absolute value bars and just solve it normally, okay? Add 3 to both sides, 15. Case 2, watch what we do, right? We have to account for the negative answer. But remember, when we have negatives with absolute value, with inequalities is what I wanted to say, right? We've got to do that whole flip the alligator, flip the inequality. So case 2, guys, still looks like this, n minus 3. I will flip this, bam. I will make this negative 12, okay? Now I solve it normally. So add 3, bam. There you go. So here's the two things to graph. Again, it's an and, guys. It's an and. So, all right, here's negative 9. Here's 15. So n values less than or equal to 15, right? I'm thinking a filled in dot, and then it goes that way. N values greater than or equal to negative 9, right? Filled in dot, and then going that way. So where are the numbers that meet both of these inequalities, right? Well, it's all this overlapping area right here, okay? So this is where, hey, all of these numbers meet this one, and they meet this one, right? By ones, we're saying inequalities. All right, so there you go. So our solution set, when graphed, bam, looks just like that, okay? Alrighty, that seemed challenging enough. Maybe we could do a couple more of those, and they won't seem as challenging. All right, so you guys are ready to solve this one? Yeah, absolutely. I mean, let's do the same thing we're doing, right? Case 1, here it is. However, that's not true. Why am I writing this up here, people? Okay, we cannot fall into bear traps. Look carefully. Chomp, 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 chomp. Okay, negative 8. Will any absolute value expression ever be less than or greater than, right? This negative, no, we cannot have that, right? So this scenario does not exist. No solution. I cannot make case 1. Don't have to worry about case 2. That was easy enough. Can we get some more of those? That'll really shorten this video down. All right, we can solve this one. Case 1 literally just looks like this, right? Here's case number 1. P plus 4 less than 6. Less than and. Subtract 4. Okay, that turns into 2. Second case, right? Keep your absolute value expression, flip your inequality, flip your number. Now we solve it. Again, subtract 4 from both sides. All right, there's your 2. It's an and. So again, I'm assuming they're going to cross paths at some point. Here's the number negative 10. Here's the number 2. P-values less than 2. Open dot on 2, going that way. P-values greater than negative 10. Again, open dot, going that way. So where are all the numbers that satisfy both inequalities? Again, all of these numbers in here, guys, all of these ones there, okay? So that's your answer. So we're an open dot on -10 because we're not including that. We are an open dot on 2 because we're not including that number either. But all of those numbers in between -10 and 2 will satisfy both inequalities right now, and that's how we show that on a graph. All right, we are exactly 33.3% of the way through the notes. Again, solve this one. What? That's right, we can't do it, guys. Again, I'm just trying to mess with you guys. Yeah, we can't. No, this does not work, okay? Again, you got to study this and say, yep, okay, whoa, red flag, light sirens, horns should be flashing off in your head to go, no, this is a no solution, right? No solution. Okay? Good deal? All right. Okay, this is what happens when your battery dies. All right, so anyway, we probably had a glitch in there somewhere. I think we hadn't started this one, or maybe I think I might have been in the middle of it, and then it died, and so then I had to cut back. Anyway, whatever, here we go. We're going to have to write absolute value expression for this one. So remember, the plus or minus number, right? Hey, it can, go up or down between this, right? The plus or minus number is always at the end of this. So let's read about the rainfall problem here. It says the average annual rainfall in California for the last 100 years is 23 inches. However, the annual rainfall can differ by 10 inches, meaning it could be 10 inches more or 10 inches less than that 100-year average. Okay, so remember, here's that general structure, right? It's always going to take the absolute value of x minus some number, and then we're going to have our inequality, so maybe a less than or a greater than, and then this is the plus or minus number, right? This is the, hey, it could be above or below that number, all right? Again, they're just looking for the range. I'm sure all of you are smart enough to figure out right now if that range is going up or down by 10, and here's the average. Okay, add 10, subtract 10, there's our two numbers, okay? But at some point in time, somebody's going to want us just to write it. They don't even care about the range, okay? So kind of think about this structure, all right? So it's going to look like this. The absolute value of x minus 23, right? And then we're either going to be less than or equal to that. No, I'm going to write 23 again. No. 10 number there, okay? So here's case one. Go ahead and solve x minus 23 less than or equal to 10. So I'm just going to add 23 to both sides. 33, I think, is what that should be. All right, case number two, guys, still x minus 23. Now, take the opposite, take the opposite. So now we are greater than or equal to negative 10, okay? Again, add 23 to both sides. X value is greater than, what is that, 13? Okay. So there's our two numbers. And again, I'm sure you could have figured out it was 33 and 13 using some brain power. Do I need to graph this? Probably not. Again, this one is a less than, so it's an and, because remember, these are all the amounts of rain we could get that meet both of these, right? They're within that 10 inches of rainfall, right? That usually is 23 inches, okay? Again, if you wanted to graph it, hopefully you're getting pretty good, right? On a number line, this would be 13, and this would be 23, okay? Okay, so there we go. I think we're moving along just nicely. Forgot to erase that. My beat. All right. Thermostat inside Macy's house keeps the temperature within 3 degrees. Where's that number going to go? Of the set temperature. If the thermostat is set at 72 degrees, what's the range? Again, this probably ain't hard. Add 3, subtract 3. What is hard is writing it, right? It's that within 3 degrees. That's your dead giveaway, okay, for plus or minus number. That's the dead giveaway for the number that goes all the way out here at the end, okay? So it looks like this. Again, we could go through and we could take those. I think we would find one temperature to be 75. I think we would find the other temperature to be 70, to be 69, okay? There you go. Again, plus or minus 3 degrees goes at the end. All right. Solve and graph, super straightforward here. I don't see a negative here, so they didn't try to trick us. So case 1, 3y minus 3 greater or than 9. So I'm going to add 3 to both sides. Okay, done. All right, case 2, change the inequality, change the number to its opposite. So case 2 looks just like this. 3y minus 3 is now less than a negative 9. Okay, add 3 to both sides, right? That's first step. 3y less than negative 6, and divide by 3. Negative 6 divided by 3 is negative 2. Go ahead and graph it. This is an OR, so we're going to be graphing kind of like both parts. All right, here's the number negative 2. Here's the number 4. I want y values greater than 4. They would be going in that direction. I want all the y values that are less than negative 2. They would be going in that direction. And there you go. It's an OR. We just graph both of them. Leave it as it is. Alrighty. Same thing here. This one's pretty straightforward. Again, if you want to try it, you just pause the video, and then you see how you did. In the meantime, case 1, guys, looks just like this, greater than 6. So 2m is greater than 8, so m is greater than 4. Okay, I saw that in super slow-mo for you guys. So there's case 1. Case 2, change your inequality to the opposite. Change your number to the opposite. Solve. Still going to add 2. Negative 4. Less than negative 2. Great OR. This is also an OR. Okay? Here's negative 2. Here's 4. This is a sweet looking number line. All right, m values greater than 4, opened out on 4, and we are including all the numbers to the right, or greater. M values less than negative 2, so opened out on negative 2, all the numbers to the left. Why? Because they're smaller than negative 2. Okay? Any questions? You guys are quiet today. All right, well, maybe that means you like something. By something, I'm referring to absolute value inequalities. Okay, last one. Why don't you guys do this one? Pause the video, try it. No, I said pause it, try it. Okay, come back, I'll show you the answers. Okay. Hey, welcome back. Hopefully you didn't do anything and you just watched it because you recognized that there was a negative 2 over here, and that can't happen. We end on a bear trap. So this last one's no solution, guys. Again, we can't have an absolute value expression, right? No, just doesn't work, okay? Anyway, hope you're doing great, and I hope you have a good day today. I hope you enjoyed our fun time here with absolute value inequalities, solving and graphing. I know I had a lot of fun. So see you guys soon. Let me know if you have any questions.